Hi, hello, welcome to home school. This is your class 11 mathematics. We are in our first chapter sets and today we are going to complete our exercise 1.5. Before starting the exercise, we are going to discuss operations on sets, last topic, that is complement of a set. What is complement of a set? Let us see the definition. Let U be the universal set. Let U be the universal set and A be the subset of the universal set. Let A be a set and this set is a subset of universal set. A complement is denoted by A dash. U is universal set, A is the subset of universal set and then A complement is written symbolically as A dash is equal to set of all x such that x belongs to universal set and x does not belongs to A. Or you may say this as A complement is equal to U minus A. In universal set, remove A elements. In universal set, other than the elements of A, we need to write in A complement. Okay, let U be the universal set and A be any subset of the universal set. Then its complement is equal to all the elements of universal set other than the A set elements. Okay, it can be written as A complement is denoted by A dash. A dash is equal to set of all x such that x belongs to U and x does not belongs to A. Or simply we can say A dash is equal to U minus A. In universal set, other than A elements, write in A complement. Okay, let me take one example here. Let universal set be 1, 2, 3, 4, 5. Okay, and A set be 2, 3, 5. Universal set contains 5 elements and A set contains 3 elements. Then what is the complement of A? Complement of A dash is equal to other than the elements of A we are saying. See here, what are the A elements? 2, 3, 5. 2, 3, 5. Other than these 3 elements, that is 1, 4. Okay, other than the elements of A means other than 2, 3, 5, write the remaining elements from universal set. That is only the complement of a set. Let us represent this complement of a set by using Venn diagram. Suppose Venn diagram universal set is represented by a rectangle U. Take a set. Universal set is represented by rectangle and its subsets are represented by circles. I have taken only one circle. This circle belongs to A set. So I have written A here and the elements of A right inside. What are the elements of A? 2, 3, 5. Okay, if you want you can put a dot and you can represent the number. And in universal set 1, 2, 3, 4, 5. 2, 3, 5 already I have written. So other than these 3 elements, what do you have? 1 and 4. 1 and 4 right outside the A subset. Right? So now A complement where I have to shade in this Venn diagram. A complement other than A, see where I am shading, observe. So this part we need to shade in order to represent A complement. shading may be any way you can do. Okay, this shaded region represents a complement. Next, we are going to discuss some properties of complement of sets. Okay, let me write here properties. Properties of complement sets. Okay, in this first one, let us see complement laws. In this, again, first one, A union A complement is equal to A union A complement. Okay, this is A set and this is complement of A set. A and A complement, you can see. Union of these two sets, that is equal to 1, 2, 3, 4, 5. What is this set? This set is nothing but the universal set. So I can say this law as A union A complement is equal to universal set. Similarly, second one, A intersection A complement is equal to intersection common elements in both the sets. What are the sets here? A set and its complement. A is equal to 2, 3, 5. A complement is equal to 1, 4. Do you have any common elements? There is no common element. So no common element means just we write null set. Therefore, A intersection A complement is equal to null set. Next one, De Morgan's law. Again, in this first one, De Morgan's laws, complement of union of two sets. Complement of union of two sets. What are the two sets? A and B. Complement of union of two sets is equal to intersection of their complements. A union B whole complement is equal to A complement intersection B complement. Similarly, second law is A intersection B whole complement is equal to A complement union B complement. Complement of intersection of two sets is equal to union of their complements. These are two laws. Anyhow, we are going to verify these laws in exercise 1.5. One main we are going to do. At that time, we are going to understand clearly. Right? Next, double complement. Double complement of a set. Suppose that is A complement whole complement. A complement means in universal set other than A elements. Then again double the complement means you are going to get simply A. Okay, let us check it out. A complement whole complement is equal to universal set. You need to remove A complement elements. Double complement, you can write this in this way also. A complement whole complement is equal to set of all x such that x belongs to universal set and x does not belongs to A complement. A complement whole complement is equal to set of all x such that x belongs to U and x does not belongs to A complement. Other than the elements of A complement, remaining elements from universal set we need to write. That is only the double complement. That is equal to A complement whole complement is equal to A complement is 1, 4. Other than 1, 4, what are the elements you can see there? 2, 3, 5. And observe carefully, 2, 3, 5 is nothing but A set. Therefore, A complement whole complement is equal to A. And coming to last one, pi complement is equal to pi complement. Pi complement is nothing but I can write it as in universal set remove pi. In universal set, if you remove empty set, you will be having universal set. Therefore, pi complement is equal to universal set U. And universal set complement is equal to U complement in universal set, remove universal set. U minus U, what you are going to get? Empty set. That is nothing but U complement is equal to pi. Okay, these are all the properties you need to remember carefully. Okay, now let's see the Venn diagrams for remaining laws. Okay, look here carefully. A union A complement. See the Venn diagram? Rectangle for universal set, and this is A set. This circle indicates A set and outside region indicates A dash. A union A dash. What you need to shade? A circle and also A dash means complete rectangle. Complete rectangle including the circular part we need to shade for A union A dash. That is nothing but universal set means complete rectangle. Next, A intersection A complement is equal to. For this, how will be the Venn diagram? Again, this is A set, universal set. A intersection A dash. A intersection A dash. Can you see the circular part intersecting the outside region? No. No means null set, so I can't shade anywhere there. Right? When you are shading, you can write this A union A dash is equal to universal set, and no shading at all. You can write this as A intersection A dash is equal to null set. Next, A union B whole complement. Take a rectangle, A set, B set, okay, A union B whole complement. A union B means complete A and B circle. Complement of these means, see here, outside region. Other than A union B, we need to shade. Okay, this Venn diagram represents A union B whole complement is equal to A complement intersection B complement. A union B whole complement is also same Venn diagram, and A complement intersection B complement also same Venn diagram. A complement means what? Other than A circle completely you need to shade. B complement means other than B circle we need to shade all. Intersection means only other than the two circles we need to shade. Okay, let's go for the next one. A intersection B whole complement. Again, take universal set and two subsets here. A, B, universal set. A intersection B complement. A intersection B means this region, and other than this complement means, see, leave this, leave the intersecting part, and share the remaining region. See, other than the intersecting part, A intersection B whole complement. Other than the intersecting part of both the sets, remaining full complete universal set we need to share. Same you are going to get for A complement union B complement. A complement means other than A circle. B complement means other than B circle. Union, A complement union B complement is also same Venn diagram. Okay, next coming to A complement whole complement. A complement whole complement. Universal set, this is a rectangle. Where I need to shade? A complement means outside the circle. Again complement means only a circle I need to shade. This indicates a complement, whole complement. Okay, is this clear? And A is also same Venn diagram. Like this, we can represent the sets by using Venn diagrams. Okay, so once let's have a quick recap of the board. Complement of a set. It is represented by A dash. A dash is equal to set of all x such that x belongs to U and x does not belongs to A, or A complement is equal to U minus A. And its Venn diagram is here. And then we have discussed the properties of complement sets. Complement laws, A union A complement is equal to universal set U. A intersection A complement is equal to null set. De Morgan's laws. A union B whole complement is equal to A complement intersection B complement. A intersection B whole complement is equal to A complement union B complement. And A complement whole complement is equal to A. Empty set, null set complement is equal to universal set complement is equal to null set. Okay, let's start the exercise now. Exercise 1.5, first main. Let U indicates universal set. U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. A is equal to 1, 2, 3, 4. B is equal to 2, 4, 6, 8 and C is equal to 3, 4, 5, 6. Find all the sub-questions. Okay, let me start with the first one, A complement. A complement, you can write it as set of all x such that x belongs to universal set and x does not belongs to A. In this way also you can write, or directly you can write it as U minus A. U minus A. In universal set, remove A set elements. What are A set elements? 1, 2, 3, 4. So observe carefully. 1, 2, 3, 4. Other than these elements, write down that is only the A complement. 5, 6, 7, 8, 9. That's it. Next, second one, B complement. B complement you can write it as in universal set, remove B set elements. What is that answer? B complement is equal to B 2, 4, 6, 8. In universal set, other than 2, 4, 6, 8. Write the remaining elements 1, 3, 5, 7, 9. That's it. In universal set, remove B set elements. Third one, A union C whole complement. How to solve these type of problems? First, let me do A union C. Then do the complement. A union C is equal to union of two sets A and C. 1, 2, 3, 4, 3, 4, 5, 6. There are two elements which are common, that is 3, 4 is common in both the sets. So write one time and write the remaining elements. That is 1, 2, 3, 4, 5, 6. Now A union C whole complement is equal to universal set minus A union C. That is equal to, in universal set, remove A union C elements. A union C, what do you have? 1, 2, 3, 4, 5, 6. Okay, other than these elements, you write remaining. That means 7, 8, 9. This is A union C whole complement. Very simple. See the fourth one, A union B whole complement. Same manner, first find A union B. What is A union B? 1, 2, 3, 4, 2, 4, 6, 8. 1, 2, 3, 4, 6, 8. Yes, 2, 4 is repeated. 2, 4 write one time. Along with 2, 4 write all the remaining elements. 1, 2, 3, 4, 6, 8. Now, A union B whole complement is the question. So, in universal set, remove A union B set elements. That is equal to A union B 1, 2, 3, 4, 6, 8. 1, 2, 3, 4, 6, 8. Other than these, you say the elements 5, 7, 9. That is only a answer. 5, 7, 9. Okay, A union B whole complement is equal to 5, 7, 9. Fifth one, double complement of A. We know this directly we can answer. A complement whole complement is A itself. But let us check it out. First find inside the bracket A complement I'll find. That is in universal set. Remove A set elements. What it is? A set elements are 1, 2, 3, 4. Other than 1, 2, 3, 4, 5, 6, 7, 8, 9 is what? Complement of A. Then again do the complement for this. A complement whole complement is equal to in universal set remove A complement. In universal set remove A complement set elements. So A complement what do you have? 5, 6, 7, 8, 9. Other than these elements, write in this 1, 2, 3, 4. What is 1, 2, 3, 4? It is nothing but A set. Therefore, finally, A complement whole complement is equal to A. Last one in this, B minus C whole complement. First find B minus C. B set 2, 4, 6, 8 minus C set 3, 4, 5, 6. Minus in the sense don't subtract elements. In this first set, remove second set elements. Try to understand carefully. In B, remove C. In B set, remove C set elements. What are C set elements? 3, 4, 5, 6. Do you have any element in this? Yes, 4, 6. Other than these two elements, remaining elements write from this set. That is only B minus C. 2, 8. Suppose if I ask you C minus B, see the common elements here 4, 6. Other than 4, 6, write the elements from C. When you have C minus B means that you need to write that is 3, 5. But now here we have B minus C. So your answer is 2, 8. B minus C whole complement is equal to in universal set remove B minus C set elements. B minus C set elements are 2, 8. In universal set, if you remove 2 and 8, what you have? 1, 3, 4, 5, 6, 7, 9. Write those. 1, 3, 4, 5, 6, 7, 9. That's it. This is B minus C whole complement. Okay. Is this clear? Second main, if universal set U is equal to A, B, C, D, E, F, G, H. These are all the subsets given and your question is find the complements of these sets. A is equal to A, B, C. B, D, E, F, G, C, A, C, E, G, D, F, G, H, A. We need to find these sets complements. That means A complement, B complement, C complement, D complement we need to find. So first one, A complement. In universal set, remove A set elements. That is equal to, in universal set, what are A set elements? A, B, C. Other than A, B, C, what do you have? D, E, F, G, H. That's it. This is only A complement. Similarly, B complement is equal to U minus B. In universal set, remove the elements of B set. B, what do you have? D, E, F, G. D, E, F, G. If you remove, you are going to have A, B, C, H. That's it. Next, C complement. Universal set minus C set. See what you have? A, C, E, G. These elements removed from universal set. A, C, E, G. If you remove, what do you have? B, D, F, H. That's it. This is C complement. Coming to D complement. D is equal to F, G, H, A. Universal set minus D set. F, G, H, A. F, G, H, F, G, H, A. So, other than these four elements, write the remaining. B, C, D, E. Therefore, D complement is equal to B, C, D, E. Okay, is this clear? Third main, taking the set of all natural numbers as the universal set and write the complement of these all sets. Okay, first we need to write the universal set. Universal set is equal to set of all x such that x belongs to natural numbers, or set of all natural numbers also you can write. So we have the universal set, then we can find the complement of all these sets. Right? First one, set of all x such that x is an even natural number. Even natural number. Okay, natural numbers, I think you can say here 1, 2, 3, 4, so on you will be having in the universal set. All natural numbers set. Set of all x such that x is an even natural number. See, even numbers 2, 4, 6, 8, so on you will get. Other than even numbers, what numbers you have in this natural number? Odd numbers. Any number in a natural number must be either even or odd. So here they have given even natural number. Its complement other than even natural numbers in the universal set means you will be getting set of all x such that x is an other than even. Complement means other than even we have odd natural numbers. That's it. So for this set, complement is this set. Okay. If any using any letters also you can denote. Suppose let it be A is equal to this is A complement, B is equal to B complement. Like that also you can mention. So coming to second one, set of all x such that x is an odd natural number. Odd natural number complement means even natural number. That's it. In universal set, if we remove odd numbers, we get even numbers. That only you write it here. Set of all x such that x is an even natural number. That's it. Third one. Set of all x such that x is a positive multiple of 3. Natural numbers means we will be having only positive numbers. And in that, other than the positive multiples of 3. Positive multiples of 3 means what you can say? 3, 6, 9, these all. Other than these numbers, write the remaining numbers. Write the remaining numbers means, how can we write that? Set of all x such that x belongs to natural number and x is multiple of 3 said here. I will write in its complement. X is not a multiple of 3. Other than the multiples of 3, I can write in complement set. Right? Next one. Fourth one, set of all x such that x is a prime number. Prime number. See, natural numbers, prime number. Other than prime number, what are the numbers we say? Composite numbers. Right? Thus, how can we write the answer? Complement of this set is set of all x such that x is a composite number, or x is equal to 1. That means 1 is neither prime nor composite number. Right? Next. Fifth one, set of all x such that x is a natural number divisible by 3 and 5. Then what is the complement of this set? We are saying divisible by 3 and 5. In universal set, you should give concentration for 3, 6, 9, same manner 5, 10, 15. Multiples of 3, multiples of 5. Other than these remaining elements in universal set, we need to write the complement. That means set of all x such that x is a positive integer which is not divisible by 3 or not divisible by 5. See here, x such that x is a positive integer which is not divisible by 3 or not divisible by 5. Other than the divisibles of 3 and 5, we need to write the complement. So we need to write the statement in this manner. Sixth one, set of all x such that x is a perfect square. What are perfect squares? 1, 4, 9, 16, 25, 36. These are all perfect squares. Other than the perfect squares, we need to write the complement. That means set of all x such that x belongs to natural numbers and x is not a perfect square. That's all. With this statement we can end it. X is not a perfect square. Right? X belongs to natural numbers and the complement of perfect square is not a perfect square. See the seventh one. Set of all x such that x is a perfect cube. What are perfect cubes? 1, 8, 27, 64. These are all perfect cubes. Other than perfect cubes, we need to write the complement. That means set of all x such that x belongs to natural numbers and x is not a perfect cube. And x is not a perfect cube. Other than perfect cubes, we need to write in the complement set. Eighth one, set of all x such that x plus 5 is equal to 8. How to do this? Okay, observe the equation. Find out the x value. Other than that value, you need to write the remaining in the complement. So first find x value. Okay, roughly anyway you can do this. X plus 5 is equal to 8. X is equal to, transpose 5 other side, 8 minus 5 will be 3. X is equal to 3. So other than 3, remaining all numbers comes under complement set. That means set of all x such that x belongs to natural numbers and x is not equal to 3. Other than 3 number, remaining all will come under complement set. Same manner, go for ninth. Set of all x such that 2x plus 5 is equal to 9. Same manner, solve that one. This is rough part. 2x plus 5 is equal to 9. Transpose 5 other side. 2x is equal to 9 minus 5, 4. X is equal to, multiple, divide. 4 by 2, it will be 2. X is equal to 2. Other than 2 number, remaining all will come under the complement set. How to write this one? Set of all x such that x belongs to natural numbers and x not equal to, you should write, x not equal to 2. 10th one, set of all x such that x greater than or equal to 7. Greater than or equal to 7. First understand this set. Greater than or equal to 7 means 7, 8, 9, 10, so on you are going to get. So from 7 you will be having in this set. Complement of this set means other than those elements. That means set of all x such that x belongs to natural number and x less than 7. That's it. Less than 7, what natural numbers are there? That is a complement of this set. Okay, here greater than or equal to 7 there. So we have written only less than 7. Last one, set of all x such that x belongs to natural numbers and 2x plus 1 greater than 10. Okay, some equation you can see there. Let us simplify that. 2x plus 1 greater than 10. So transpose other side, 10 minus 1 will be 9. X is greater than 9 by 2. What is x value you got? X is greater than 9 by 2. So in that set, greater than 9 by 2, all the natural numbers will be there in that set. So complement. See, greater than means that number won't be there. So complement of that set, how can we write? Set of all x such that x belongs to natural numbers and x less than or equal to 9 by 2. Observe here carefully, greater than 9 by 2. So 9 by 2 and it's less than natural numbers will be there in that complement of a set. Okay, so understand carefully here, greater than or equal to 7 means 7 will be there. So complement of set means less than 7 we have set. Same manner here, greater than 9 by 2 there. Greater than 9 by 2 means equal to 9 by 2 and less than comes under complement of a set. Fourth mean, if universal set U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, A is equal to 2, 4, 6, 8 and B is equal to 2, 3, 5, 7. Verify De Morgan's laws. That is, A union B whole complement is equal to A complement intersection B complement and A intersection B whole complement is equal to A complement union B complement. Okay, let us see the first one here. Whether this equal to this or not, we need to verify. Okay, let me consider LHS part. Left hand side, A union B whole complement. Before finding this complement, we will find A union B first. A union B is equal to A union B. Write the elements of A set and B set. Common elements, write one time. So 2, 4, 6, 8, 2, 3, 5, 7. A union B. 2, 3, 4, 5, 6, 7, 8. Write in an order. 2 repeated. So write one time. 3, 4, 5, 6, 7, 8. Its complement. A union B whole complement is equal to. In universal set, remove A union B set. That is equal to. In universal set, other than these elements, 2, 3, 4, 5, 6, 7, 8. From here to here, if you remove, what are the elements left over? 1, 9. This is A union B whole complement. Mark this as first equation. Now consider RHS. Right hand side, what do you have? A complement intersection B complement. Before finding this, separately you find A complement and B complement, then do the intersection. Okay? A complement other than A set elements. 2, 4, 6, 8 you remove and write 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. Then coming to B complement in universal set, remove B set. 2, 3, 5, 7 you remove 2, 3, 5, 7. Other than that, what do you have? 1, 4, 6. 5 already there, right? 1, 4, 6, 8, 9. That's it. Now next, A complement intersection B complement. Intersection means write only common elements from both the sets. Common elements identify. 1 is repeated and 9 is repeated. That's it. 1, 9. Mark the second equation. Observe first equation and second equation. What you can say? Both are equal. Therefore, from equation 1 and 2, LHS is equal to RHS. That is, A union B whole complement is equal to A complement intersection B complement. Hence, it is verified. Similarly, let's go for the second law. A intersection B whole complement is equal to A complement union B complement. Same manner, first consider LHS. Find A intersection B complement. First find A intersection B. What is A intersection B? 2. That's it. Only 2. 2 is A intersection B. A intersection B complement means other than 2 elements, remaining elements in universal set. That is 1, 3, 4, 5, 6, 7, 8, 9. That's it. Okay, mark this first equation. Next, consider RHS. Right hand side, what do you have? A complement union B complement. Find A complement first. A complement already we found here. We can write directly. 1, 3, 5, 7, 9. And B complement is 1, 4, 6, 8, 9. Now next step, A complement union B complement. Union, combination of 2 set elements. Write the repeating elements one time. So what are the elements repeated here? 1 is repeated, 9 is repeated, right? So union of these 2 sets, 1, 3, 4, 5, 6, 7, 8, 9. Mark the second equation and observe carefully. 1, 3, 4, 5, 6, 7, 8, 9. Both are equal. Therefore, from equation 1 and 2, LHS is equal to RHS and A intersection B whole complement is equal to A complement union B complement. Hence, it is verified. Okay, these are the 2 laws of De Morgan's. Fifth main, draw appropriate Venn diagram for each of the following. You have 4 sub-questions. Let us see the first one, A union B whole complement. Always we represent the Venn diagram universal set with a rectangle. Universal set U, and you can see here 2 subsets A and B. So let me draw subsets with the circles. A, B, and yeah, Venn diagram A union B whole complement. A union B already we have seen in the starting of the video. A union B whole complement means other than A union B remaining part you need to share. A union B means complete 2 circles. Other than 2 circles you share. This represents A union B whole complement. Okay, shade neatly. That's it. Now, next one, A complement intersection B complement. A complement intersection B complement. You may get the same Venn diagram, but once again, let us check. Universal set U with a rectangle. A set, B set with the 2 circles. A complement means other than A circle. See here carefully. other than a circle, remaining outside part, everything will come under a complement. Just, this is not actual Venn diagram. Okay. See carefully. This is A complement, right? Now B complement means other than B circle. Other than B circle means this complete circle I don't want. So other than B circle, remaining shade like this. Just try to understand carefully. A complement means, see this dark shading. B complement means stripes. Now, both intersection. This shading and this shading, where does it intersect means? See here. See here, only lines you can see. I don't want this part. And only shading I can see here. And where these two designs are intersecting means, see, other than the two circles region, that is nothing but A complement intersection B complement, or same Venn diagram you can see. This is to explain I have done double shading, right? Normally have to draw A complement intersection, B complement is same manner you need to do. A complement intersection B complement, same Venn diagram you can write, and you can say A complement intersection B complement. Here double shading there, so we need to show only one shading. This is only to understand. Okay, so see the third one, A intersection B whole complement. First, universal set with a rectangle and universal set U. Two subsets A, B, A intersection B whole complement. First observe A intersection B means, see only this part. A intersection B means only the tiny region what I have shaded. But we need to find the complement of it. That means A intersection B whole complement. Other than the shading region, other than this part, we need to shade complete universal set. Other than intersecting part, completely you need to shade, including circles. Only intersecting part we need to leave. So other than the shading region, other than this intersecting region, completely we need to shade the universal set. Okay, this indicates A intersection B whole complement Venn diagram. See, observe here, A complement union B complement also comes under same Venn diagram. You can say A complement union B complement as same Venn diagram. But try to understand. Let me draw a rough Venn diagram here. Universal set. Okay. And again two circles A, B. Right. First, A complement will understand. A complement means what? Other than A circle. So other than A circle, shade remaining part. Just to understand this Venn diagram, but don't do this one in exam. This is B and this. Okay. This is A complement other than A circle. Now, B complement means other than B circle. So, this one also you need to shade. So, differently you shade with the lines other than B circle. Now, see here, this dark shading shows you A complement. Lines shows you B complement. In between what you have? Union. Union means both this dark shading and line shading, both I need. Union, combinedly these two shadings where you have, combinedly you need to shade. That means other than this part, remaining part in universal set you need to shade. That is nothing but this one. And same manner, this one also don't do, this one also don't do. Only for understanding these two Venn diagrams. Coming to sixth one. Let U be the set of all triangles in a plane. Universal set contains all the triangles. If A is a set of all triangles with at least one angle different from 60 degree, with at least one angle different from 60 degree, what is A complement? Here, one angle is different from 60 degree. Now its complement angle is equal to 60 degree. Suppose if all the angles are 60 degree, what I can say? It is a equilateral triangle. Right? Universal set contains set of all triangles. And A set contains all the triangles with at least one angle. At least one angle different from 60 degree. At least different. So it is equal, I'll say, in the complement. That means what is A complement? A complement is the set of all equilateral triangles. Okay. So one angle different from 60 degree and its complement is the angle is equal to 60 degree. Then if all angles are equal to 60, what we can say the triangle? Equilateral triangle. So therefore A complement is a set of all equilateral triangles. Seventh main, fill up the blanks to make the statement true. A union A dash. A union A complement is equal to what? While we are seeing properties, while we are doing the properties, we have seen this. A union A complement is nothing but the universal set. Second one, pi complement intersection A. Pi complement means full universal set. Universal set intersection A is what? Universal set means it contains all the elements of A set. Intersection common means A set is common in universal and A set. That is, pi complement intersection A is equal to A. Third one, A intersection A complement. A set intersection A complement. A complement means other than A. Other than A set and A set, do you have any common elements? There are no common elements. That means A intersection A complement is equal to null set. Okay. Next. Last one. U complement intersection A. Universal set complement. In universal set, if you remove U, you are going to get empty set or a null set. Null set intersection A will be null set. That is pi. U complement intersection A is equal to pi. With this, we are going to complete our exercise 1.5. We are going to meet in our next session with the last exercise. Until that, keep watching. Thank you all.